Hello everyone. In this video we're going to be finding the nth term of a sequence given by this recursive formula. We have a sub n plus 1 equals 2 times a sub n plus 1. N is greater than or equal to 0 and a sub 0 is equal to 0. So in order to find the nth term or a sub n here, we're going to use generating functions, and I believe this is the first video we do on generating functions, so I'm excited. So let's go ahead and define what a generating function is. So we are talking about a function that you can write like this. F of x is something that you can write as a sub 0 plus a sub 1x plus a sub 2x squared, so on and so forth. Actually, this is not like the function in the proper way of defining functions, but more like a power series. But for our purposes, this is going to work real well. So we can express a generating function with sigma. And we can basically write it as n equals 0 to infinity as sum of a sub n x to the power n. Now the critical part here is we are going to just use any variable x, and it doesn't even have to converge here, that doesn't matter. But the good part about a generating function is that the coefficient of x to the power n here is going to give us what we're looking for. So at the end we're going to get something like this, and a sub n is just going to come up from there. Okay, great. So now let's go ahead and take our equation. We have the a sub n plus 1 equals 2a sub n plus 1. Now, in order to turn this into something that looks like the generating function, let's go ahead and multiply both sides by x to the power n, and then use sigma to add it all over the place. So this is what it's going to look like. N equals 0 to infinity a sub n plus 1 x to the power n equals n equals 0 to infinity 2a sub n plus 1 times x to the power n. So we have two sides here, the left hand side and the right hand side. I'm going to be working on each side separately, and then I'll put it together. Okay, that's how I'm going to find the generating function. Okay, now let's take a look at the left-hand side, and to get a better idea, let's go ahead and expand some terms. So for example, if n is equal to 0, we get a sub 1 x to the power 0, which can be written as a sub 1 actually. So let's just go ahead and write it as a sub 1. And then if you replace n with 1, you get a sub 2 x to the first power, which is x, and then we get a sub 3x squared, so on and so forth. Now I want to focus on the left hand side on this sum first. Now if you go ahead and compare it to our generating function, we can basically say the following. And first of all, we have to pay attention to the fact that a sub 0 is 0. So our generating function actually can be written without a sub 0. So I can write our generating function as f of x equals, without the a sub 0, it's going to be a sub 1x, a sub 2x squared, a sub 3x cubed, so on and so forth. Now, if you compare these two sums, you'll notice that the expression on the left-hand side can actually be written as our expression f of x divided by x. So this gives us f of x divided by x, because when we do so, we're going to get the this sum here, okay? When we divide f of x by x, we get the sum that is on the left-hand side of our equation. Great. So that's what we get from there. How about the right-hand side? Well, if you look at the right-hand side, we want to go ahead and separate them first. Obviously, there's a plus sign here, so I can just write them as two sigma sums, and this 2 can be taken out. So it's going to look like this. 2 times the quantity n equals 0 to infinity of a sub n plus n equals 0 to infinity x to the power n. Great. Now, if you look at this expression right here, whoopsies. All right, let's take a look at this one. So this one is the same as our generating function, isn't it? So in other words, this is just f of x, isn't it? Well, there's a 0, but as you know, a sub 0 is 0, so that's fine. So we can write it as f of x divided by x equals 2 times f of x. Remember, this is the same as f of x because this is how we defined f of x, our generating function, right? This one. So it's the same thing. And Then what about the other part? Well, if you look at this sum, it's going to look like this, 1 plus x squared. This is like the geometric series. And we don't really care if this is going to converge or diverge. We just need to write it in terms of x. And it's going to look like this, 1 over 1 minus x. You know the geometric series formula. It is a1 divided by 1 minus r being the common ratio. Great. So now we got an equation for f of x. Let's go ahead and solve for f of x. And let's multiply both sides by x first. So let's multiply by x and solve for f of x. That's my goal. Okay, let's do it. So now I'm going to get f of x equals 2x f of x plus x over minus x. And then let's put the f of x's together. That's going to give me f of x times the quantity 1 minus 2x equals x over 1 minus x. And since I want to solve for f of x, let's go ahead and divide both sides by 1 minus 2x. And that's going to give me the following. X divided by 1 minus 2x multiplied by 1 minus x. So this is our generating function, but I want to be able to write it like this with the a1, a2, and a3 and all that given. So I don't really have it as a sum, but more like the result of a sum as in closed form. So I want to write it as a sum. And for that purpose, I'm going to use partial fractions. So let's go ahead and split it up into two fractions. Let me show you how that's done. We can basically write this as a sum of two fractions. So x over 1 minus 2x multiplied by 1 minus x can be written as a over 1 minus 2x plus b over 1 minus x. Because the factors in the denominator are both linear, I can use a and b in the numerator. Now, if you make a common denominator from here, you're going to get something like this. X equals a times 1 minus x plus b times the quantity 1 minus 2x. As you know, the denominators don't matter once you make a common denominator. And let's use our common trick here. What's the trick? Let's replace x with something because this equation is true for all values of x. Of course, we don't want to make it undefined. But for example, if x is equal to 1, we're going to get something like this. 1 equals, from here, we're going to get 1 minus 2, which is negative b. So this means b is equal to negative 1. If you replace x with 1/2, then we get a times 1/2, which is 1/2 of a. And on the left-hand side, we get 1/2 equals 1/2 of a. And from here, we get a equals 1. So we got the values of a and b. This basically gives us our sum as a sum of two fractions. So it's going to look like this. 1 over 1 minus 2x. By the way, this is my generating function. So let me rewrite that. It is f of x. And f of x is equal to 1 over 1 minus 2x minus 1 over 1 minus x. So now notice that these are two geometric series. So we can kind of work backwards with this. And if you remember the formula a1 over 1 minus r for a1 plus a1r plus a1r squared, you can basically turn these into the following. The first one is going to be 1 plus 2x plus the 2x quantity squared plus 2x quantity cubed, so on and so forth. And the other expression is just going to be 1 plus x squared, so on and so forth. As you know, this is the geometric sum we just talked about, right? Okay, great. Now, I want to be able to simplify this because my goal is to remember to write this as something like this. a0, a1x, dot, dot, dot. And my goal is to get to something like this. a sub n times x to the power n. So let's go ahead and do that now. That is where we are. So now I see the 1 minus 1 cancels out. So that doesn't matter. Let's go ahead and focus on the x values here. I have 2x and I have x. So I can write it as 2 minus 1x. And this is important to be able to write it that way instead of just writing 1x. This gives me 2 squared x minus 1. 2 squared x squared minus 1. So I can write it as 2 squared minus 1 quantity x squared. And then I can write it as 2 cubed minus 1 x cubed, so on and so forth. Now, I want to be able to write it as a sum. So now let's go ahead and write it that way. We can just write this as n equals 0 to infinity, 2 to the power n minus 1, because the first term is 2 to the power, well, 2 to the power 0 is 1, 1 minus 1 is 0, so that doesn't matter. We can start at 0. It's not important, but we can just use x to the power n here, because that's just going to give us a 0 times 1, right? So this is going to be our generating function, which is f of x. And guess what? This gives us the coefficient of x to the power n is going to give us our sequence. So our sequence that we were trying to solve is 2 to the power n minus 1. All right? Now let's go ahead and take a look at our original sequence and see how it relates to the result that we found. So if you remember, our original problem said that a sub n plus 1 can be written as 2a sub n plus 1, and a0 was equal to 0. So we start with 0, double and add 1, that gives us 1, double and add 1, that gives us 3, and then 7, and then 15, and then 31, so on and so forth. And if you look at all these terms of the sequence, you're going to notice that they are all less than 1 less than a power of 2. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.